Hey guys, in the last video I got cut off at the end. We were talking about this function f of x, and we determined that the end behavior, not the end behavior, I'm sorry, the behavior as we approached -3 and -2, the asymptotes, as we approached -3 from the left, we had, I'm going to do it on a different color here. We had, we determined that as x was approaching 3 from the left, as it approaches that vertical asymptote, it was going towards positive infinity. And as we approached -3 from the right, we were going towards negative infinity. And then as we were going towards -2 from the left, it was going towards negative infinity. And as we went approached the vertical asymptote of x equals -2 from the right, then we got positive infinity. And then if you look at the graph, you can see in this graph here, we have asymptotes at -2 and -3, and it follows that it approaches positive infinity on the left of -3, negative infinity on the right of -3, negative infinity on the left of -2, and again positive infinity on the right of -2, which matches what we determined. And the only thing we were determining there is what's happening near the asymptotes. The rest of the graph we have to dig in a little bit more. Okay, so let's do the second example in your notes with g of x, which is x squared minus 1 over x plus 1 times x minus 2. So what you want to do here is we want to factor. Let's start by factoring this numerator. I'll move myself over here. So it's a difference of squares again, same as the previous example. It's going to factor into x plus 1 times x minus 1. And then I have divided by x plus 1 times x minus 2. So notice we have the same factor in the numerator as we do in the denominator of x plus 1. We can remove that factor. Back here in the notes from the previous video, if there is no identical factor in the numerator, there is a vertical asymptote there. On the other hand, if there is an identical factor, which we have of x plus 1 in the numerator and denominator, we have what's called a removable discontinuity. So g of x has a removable discontinuity, and if you think about this, we can remove that factor, so that can help you remember that that's where you're going to have a removable discontinuity, because we can remove it. It has a removable discontinuity at x equals -1. If the factor is x plus 1, then the 0 is -1. And this one cannot be removed, so we have a vertical asymptote at x equals positive 2, which is what would make the denominator equal 0. The denominator is 0 at x equals -1 for this because of that factor, and at positive 2 for the other factor. But because we can remove that factor, it creates a different, creates something different for the graph, the meaning of the graph. Okay, so now we need to find our behavior near the asymptote. So the limit of g of x, as x approaches 2, we're going to go from the left, and as x approaches 2, we go from the right. So you write 2 with a little plus sign, that means from the right. So this top one, let's look at what happens as x approaches 2 from the left. So think of a number that's to the left of 2, like that's really close to 2 though, like x equals 1.9. And we're going to plug it in, and you can use the simplified version of g of x, which is x minus 1 over x minus 2, and we're just going to determine if we're going to have a positive or a negative result. If it's positive, it goes towards positive infinity. If it's negative, it goes to negative infinity. So if I put in positive 1.9 for x, 1.9 minus 1 is going to be a positive, and then in the denominator, 1.9 minus 2 is a negative. A positive divided by a negative is negative. You go ahead and do the 2 from the right and see what you get. And you can pause the video to do that and come back. As x approaches 2 from the right, I'm going to use a number like 2.1. Putting that in here, 2.1 minus 1 is a positive, and 2.1 minus 2 is a positive. Positive divided by a positive is going to give us a positive infinity. All right, so this is what the graph of g of x looks like. And notice that as we approach 2 from the left, we end up going towards negative infinity, and as you approach 2 from the right, we go towards positive infinity, just like we thought. All right, so that is the second example. In our next video, we'll go over how to determine the horizontal asymptotes of a graph.